second way to do it, we have this base equation to start with. Well, we don't really have an E-gen, generated energy. This is going to be 0. Then we're going to take derivative of C1. And we're going to divide it by K. But since K is also just a constant, so what we can do is just consider it as a C1. It's going to make our job a little easier. And then we take an integral again to make it C1 C1x plus C2. So we can have these two equations. Can have one for skin, and we can have another one, same thing, for clothes, C4. And we have some basic assumptions. We have to make some assumptions and set our boundary condition. So at x is equal to 0, and let's draw it horizontally. This is skin and clothes. Let's call it 0, L1, and L2. This boundary is TCS, this 37, this 30. T infinity, TS. So at x is equal to 0, we know that this is 37 Celsius. If we plug it in to the C1x plus C2, 37, so it gives us that C2 is equal to 37. Second boundary condition is x is equal to L1. So at T1 L1 is C1 L1 plus C2, just plugging in the L1 into this equation. At T2, since this is the interface of both skin and cloth, both equation applies in this area. So it's C3 L1 plus C4. We can combine this, and we know they're same temperature at this interface. So we can say C1 L1 plus C2 is equal to C3 L1 plus C4. And at x is, another thing we can derive is that the two conductions are same through the at this L1 from skin and cloth. So call it cloth, skin. So we can represent it as negative K1 dt1 dx at L1 is equal to negative K2 dt2 dx at L2. So we have noted that dt over dx is equal to C1. And if we solve it for C3, we'll have dt over dx equal to C3. So we can replace it, this dt1 over dx, C1 negative C2, C3. Last boundary conditions is that x is equal to L2, so over this region. So t is equal, x is equal to L2, and we're using T2 equations because we're doing it for the clode. And that is equal to C3 L2 plus C4. And that should be equal to 30. And that's our another equation that we're going to use. Currently, there are three unknown, and which is C1, C3, and C4. We know C2, and L1 is given, which is 1 millimeter. And negative K1 and K2 are given. K1, K2. L2 is the 1 millimeter plus 2 millimeter. It's going to be 3 millimeter. Now you can set up a matrix. So let's rewrite it so that it's convenient for us to solve it. C1 L1 minus C3 L1 plus C4 is equal to negative C2. We know negative C2 was 37, so it's going to be negative 37. K1C1, negative K1C1 is equal to negative K2C3. So let's write negative K1C1 plus K2C3 is equal to 0. And lastly, negative C3L2, oh, not negative, C3L2 plus C4 is equal to 30. So C1, so we're going to put L1, negative K1, and 0. C1, C3, C4. So for C3, we have negative L1, positive K2, and L2. And then C4, we have 1, we have 0, and then 1. We have 1, yes. And then those are equal to negative 37, 0, and 30. And if you plug it into calculator, you get C1, negative 1400, C3, negative 2800, C4, 38.4. This gives us that T1x is equal to negative 1400 x plus 37, and T2x is equal to negative 2800 x plus 38.4. Given this new equation, we can figure out the TCS. We can use either T1x or T2x to figure out the TCS, the temperature at the interface. But I'll just use the first one, T1X. I know that L1, negative 1400, this is at 1 millimeter, so 0.001 meter plus 37. And this should give me 35.6 Celsius, which is a reasonable number as it is between 37 and 30. And then we can calculate the new heat flux through the skin. So this is through conduction. And we can either use through the skin or the cloth. We either use this, negative K2, so we can do K1, which is 1.5, and T, so 35.6 minus 37, or dx, which is 1 millimeter, 4.001 meter. Or we could do negative 0.75, 30 minus 35.6. So this is through the cloth, this is through the skin. And dx of 0.002 meter. And either way, it should give you the value of 2100. And these are the two ways to solve this problem.